Good evening to you one and all. Let us start the practical applications of Bernoulli Equation. Generally, there are three practical applications for this Bernoulli equation. One is Venturi meter, another one is orifice meter, another one is Pitot tube. In this video class, let us discuss the Pitot tube. Let us draw a liquid is flowing through a channel or a pipe. I am representing fluid. It is a liquid flowing through a pipe. Now I am drawing Pitot tube. So we are considering this is the Pitot tube. Pitot tube. Pitot tube is nothing but a glass tube which is bent in L shape. L shape. This L shape bent Pitot tube is used to measure the flow of the fluid through a channel or pipe. Okay, this is also an application of Bernoulli equation. Already I stated it. Here is one to apply the Bernoulli equation. We need 2 points. That is, here I am considering 1 point 1. Just nearer to this second point. Okay. Let us consider the flow of fluid from this left side to right side. See, the water is flowing. As it is flowing, what will happen? So water will inserted or flows into the tube, and it may rises up to the certain level. Just here 1 and 2. We can consider. Okay. H. This is capital H and this is small h. Capital H and small h. Okay. Let us see the description. Let us consider Let us consider P1 is a pressure of water at 1 section or section 1 V1 fluid velocity of fluid at section 1 Z1 datum head of the fluid at section 1. Okay. Capital H is the depth of the Pitot tube. Depth of the Pitot tube in the liquid tube or pipe, liquid pipe. Small h, rise of liquid level in the Pitot tube. Liquid level in the Pitot tube. Okay, let us consider P1 is the pressure of the fluid at section 1. V1 velocity of the fluid, and Z1 we consider one common datum. This will be the height, Z2, and this will be Z1. And H is the depth of the tube, Pitot tube in the liquid. Capital H, small h is the rise of the liquid in the glass tube. And similarly, section 2. Similarly, enter section 2. Okay. Section 2. P2, the pressure of liquid fluid or liquid. Z2 is the HE, height of half or simply datum head. At the section. Here, velocity is equal to 0. How this velocity is becoming 0? Because there is a water obstruction. As the water is flowing to this tube, it will be stopped. Understand? So, velocity will become 0. So, that point is called as a stagnation point. Okay, the pressure at stagnation point is called as stagnation pressure. Energy will neither be created nor destroyed, but it will be transformed from one form to another form. Okay, so this if velocity is 0 means kinetic energy will be vanished. Understand? It will not be vanished, but the kinetic energy is completely changed into pressure energy. So because of this pressure energy, water will rise up. That is why water is moving up into the Pitot tube. This is the important point. At stagnation point, velocity is equal to 0. The pressure is called stagnation pressure. At stagnation point, kinetic energy will be converted to the pressure energy. Okay, these are the at stagnation point, pressure is called stagnation pressure. Okay, and let us apply the Bernoulli equation. By applying the Bernoulli equation for section or point 1 and point 2. Let us apply the Bernoulli equation for point 1 and point 2. P1 by 2z plus V1 squared by 2z plus Z1 is equal to P2 by 2z plus V2 squared by 2z plus Z2. Put Z1 is equal to Z2 and V2 is equal to 0. Therefore, what we will get P1 by 2z plus V1 squared by 2z plus Z1 is equal to P2 by rho z plus 0 by 0 plus Z2. Z1 will be gets cancelled with each other because same, understand, Z1 and Z2. These are the gets cancelled with each other. So what is the remainder? What is the remainder? P1 by rho z V1 squared by rho z is equal to P2 by rho z. Here P1 by rho z is equal to H, project head in the pipe. P2 by rho z is equal to H plus small h, pressure head in Pitot tube. See how this pressure head is increased at this second point. At the second point, velocity is 0. So kinetic energy is converted to the pressure energy. So this much increase in pressure head takes place. Okay. Cos P1 by rho g plus V1 square by 2z is equal to P2 by rho z. Capital H. Take it as equation 1. Put above things in equation 1. P1 by rho z plus P1 square by 2z is equal to P2 by rho z. P1 by rho z is equal to H plus V1 square by rho z is equal to capital H plus small h. This is P2 by rho z. Capital H gets cancels. So V1 square is equal to V1 square by 2z is equal to small h. Implies V1 square is equal to 2zh. V1 is equal to square root of 2zh. 2zh. So at point 1 or with this velocity, liquid is flowing in the pipe. The velocity flowing in the pipe is equal to square root of 2zh. Okay, from Q is equal to AB, we can calculate the charge through the Pitot tube. Q is equal to AB. A is nothing but where? Where A is the area of the pipe. This is equal to pi by 4 d square. By using this Pitot tube, we can find out velocity of the water in the tube and as well as discharge through the pipe. Okay, let us discuss the momentum equation. Momentum equation is the equation based on which it gives the information about the conservation of momentum principle. Conservation of momentum principle. It is based on conservation of momentum principle. What is the statement? What does this statement says? If we apply some force on a body of mass m, then there is a change in momentum of that body and it will be changed in the direction of applied force. Once again I am repeating. When we apply some force on a body of mass m, then there will be a change in momentum of the body and the change takes place, change in momentum takes place in the direction of applied force. Okay, from Newton's second law of motion, from this Newton's second law of motion, F is equal to ma. F is equal to ma. A is nothing but dv by dt. The rate of change of velocity is nothing but acceleration. Okay, so by using class m into, we can write dmv by dt. By which m is a constant. So we can take this constant into the differentiation bracket. By cross multiplication, we can write is equal to dmv. By applying integration to the above equation. F is equal to dmv. As the applies force, definitely velocity will be changed. Therefore, we represent the limits. Initial velocity one limit, final velocity another limit. Okay, so we will get F into t. This is equal to m into v2 minus v1. M into v2 minus v1. Okay, means F into t is nothing but impulse. But F into t, that is force multiplied with time, is called impulse. So I is equal to F into t is equal to m into v2 minus v1. Because of this impulse rate, we are calling it as an impulse momentum equation. Impulse momentum equation. So what is this? I is equal to F into t is equal to m into v2 minus v1. Impulse momentum equation. See, this equation has very much importance in analyzing the forces which may exert by the fluid on the pipe bends. Very important. And also we can calculate the reaction offered by the pipe bend to the fluid. Okay. Let us see the derivation of derivation of expression for reaction offered by pipe bend to the flowing fluid or liquid. So consider one pipe bend. pipe bend. I am representing axis. Two sections. Direction of flow. Axis is making an angle theta with the horizontal. Here also it will make an angle theta. Here the force P1 A1 is acting at section 1 P2 A2 is acting at section 2. Okay. Here we have to consider the forces acting in the direction of the fluid, in the direction of the horizontal. So here is a pipe bend. So what is our aim? To derive the expression for reaction offered by the pipe bend. So this is the reaction Rx direction. And this is the Ry direction. Being it is in inclination, the reaction will have horizontal component and as well as vertical component. Pipe fluid is entering at velocity v1 and leaving at velocity v2. Okay, so here we have to resolve the two components. What is this? Velocity theta, v2 cos theta and v2 sin theta. Resolution of v2. Resolution of P2 A2. P2 A2 cos theta, P2 A2 sin theta, P2 A2 cos theta, P2 A2 sin theta. These are the two. Here, what are the forces? What are the forces acting on the fluid? This is Fx direction, horizontal direction, and this is a vertical direction. We are going to take the net forces acting on the pipe bend. Otherwise, reaction offered by the pipe to the fluid in x direction. The net forces the various forces acting on the pipe bed. So consider net force acting on the fluid by pipe bed is P1 A1 minus P2 A2 cos theta minus Rx. This is the force. Okay. Rx is a reaction. One thing here we have to understand. In the examination, if you find the information like that, calculate that and derive an expression for force exerted by the fluid on the pipe bed, then you represent Fx and put it positive. Okay. But in examination, if you find derive an expression for the reaction offered by the pipe bed and the fluid, then put a minus. Why this difference came? If fluid is exerting the force on the pipe bed, then Fx will become positive. Okay. In other case, reaction is offered by the pipe bed, it will be negative direction. This is the thing we have to understand. This is equal to net force is equal to change in momentum. Change in momentum. This is equal to m into change in velocity. That is equal to m into v2 cos theta minus v1. M is equal to rho q. Mass flow rate is equal to rho AV, v2 cos theta minus v1. AV is nothing but rho q. So v2 cos theta minus v1. P1 A1 minus v2 A2 cos theta minus Rx. So we need the reaction offered by the pipe bed on the fluid. So write the expression for Rx. P1 A1 minus P2 A2 cos theta minus rho q into v2 cos theta minus v1 is equal to Rx. Okay. Rx is equal to P1 A1 minus V2 A2 cos theta. Write this minus V1 term before this. So minus into minus plus rho q V2 cos theta minus V1 minus V2 cos theta. Rx. So, like this, Rx is equal to rho q V1 minus V2 cos theta minus plus V1 A1 minus P2 A2 cos theta. So, by using this expression, we can calculate the horizontal component of the reaction offered by the pipe bed. Okay, similarly calculate at force in vertical direction. For beginning or section 1, there is no vertical component. Only at section 2 we have P2, A2, sin theta. This is also minus. And Ry, reaction vertical component. This is equal to M into change in velocity. This is equal to M into V2 sin theta minus 0 because at V1 is equal to, since V1 is equal to 0, as there is no vertical component for velocity at section 1. Why means we can resolve this V1 into two components, V1 cos 0 and V1 sin 0, because at inlet fluid is flowing horizontally, cos 0 1. That is why for the here we have V1 cos 0. Cos 0 is a 1. V1. That is why we got the terms V1. But here V1 sin 0 is equal to 0. Therefore V1 sin 0 is equal to 0. Therefore Ry is equal to, what's the repeat, minus V2 A2 sin theta minus Ry is equal to M. Put M is equal to rho cube V2 sin theta. Therefore minus V2 A2 sin theta minus rho cube V2 sin theta is equal to Ry. Ry is equal to, take the minus as a common one, P2 A2 sin theta plus rho cube V2 sin theta. This is the expression for vertical component of the reaction offered by the pipe bend on the fluid. So we have horizontal component and we have vertical component. So how to find out the total reaction? Total reaction offered by pipe bend of the fluid. R is equal to square root of Rx square plus Ry square. By using this equation, we can find out the total reaction. And also, we can calculate the direction of resultant force. Theta is equal to tan inverse F Ry by Rx. This is the simple information regarding the force exerted by the pipe bend or reaction exerted by the pipe bend into the liquids. Thank you.